Now arrays. It's a collection of elements which are continuously located in memory and which stores homogeneous data. The members are also called as indexed variables or subscripted variables, and they are grouped and known by a single name which is called as array name. They are very easy to handle, and though it has some disadvantages, the accessing is very easy. We can directly go to an element in order of one time. If we have 5000 values, we can take the 4000th value straight away. If A is the name of the array, then A of 4000 or A of 3999 will take us to the 4000 value straight away. So likewise, we can access elements if we know the index of that element. It's very easy and very fast. Then linked list is a collection of data elements, same as the case of arrays. Array is also a collection of data elements. Linked list also form a collection of data elements. It's having two parts. The component of linked list are called nodes. The node is divided into two. One is the information part and the other is the link part. Information gives the data we need for processing in a program, and link is the address of next node. They can be implemented using pointers. All these things will be seeing in detail in the coming chapters. So I am just going through the description as fast as I can, because you might have gone through these topics in your graduation level. So we'll be seeing this in detail in coming classes. Then stack is another one. Although stacks can be implemented using arrays and linked list, it can be defined as an extension to the above two data structures. Stack is an algorithm or a data structure which is being organized due to its implementation. It is also a collection of elements. Here the elements may be added or removed at one end of the structure, which is known as top of the stack. We will be using some technical terms associated with each of the data structures. So with stack we will be using top of the stack. Addition of an element appears at the top end of the stack, so as removal of the item. Two operations are being performed on a stack. Removal is known as pop and addition is known as push. Push means adding elements into a stack. Pop means removing an element in a stack. With these operations, push and pop, we can access only or perform only one value. That means with the pop operation we can add only one value. With the push, with the pop operation we can remove only one value. With the push operation we can add only one value. If we need to add two values, we need to use two push operations. Due to the accessing process, it is called as last in first out structure, LIFO structure. Whatever element that is being added last is being taken away first. So it's called as last in first out algorithm or structure. Then queue is another data structure. which is slightly different from stack, because the accessing operation is performed on opposite ends of the structure. It's a linear list. The elements are added at one end and they are removed from the other end. The technical terms used for added end is rear and the removal entry is front. Due to this operation style, it is called as FIFO structure. Whichever value entered first is removed first. So it's a first in, first out data structure. So these are the examples of linear data structure where we can specifically say that this element is coming before the other element or this is coming after another element. Such type of structuring is called linear data structure. Arrays, linked list and stack and queues are the examples of linear data structures. And now let us move on to non-linear data structures. It is just an opposite structuring technique. Here the data values are not arranged in order. One data item may be connected to different other data items, whereas in linear data structure we have one-to-one connection. Here we have one-to-many or many-to-one connection. Associated with one value, we can move to many values at the same time. So such ordering is called as non-linear data structure. It uses memory efficiently. So the two types of non-linear data structures are tree and graph. Tree is a flexible, versatile and powerful non-linear data structure. For many of the problems we will be using tree for solving them. Especially for searching techniques, we will be using tree data structure. It's a hierarchical relationship, specified data structure. And it is dealt with data structure for representing hierarchical data. Graph is another non-linear data structure which consists of a finite set of ordered pairs called as edges, and these edges will be connecting some nodes or vertex. So we have a connection from vertex to vertex using edge. In tree also, nodes are being connected to other nodes. So we will be seeing trees and graphs in our later lessons or modules. Now let us go on to abstract data type. The short form of this word is ADT. It's a standard short form. ADT stands for abstract data type. It is an abstraction of data structure. It is a mathematical model of a data structure. It describes a container which holds a finite number of objects where the objects may be associated through a given binary relationship. It's a logical description of how we view data and the operations allowed without regard to how they will be implemented. Actually, ADT means a collection of data, and these data can be manipulated using many operations, and the whole collection, that is data plus the operation performed on these data, are collectively called as abstract data type. So what is ADT? Data plus the operation, all possible operations, that is that we can use for performing on these data, are collectively known as abstract data type. ADT concerns only with what the data is represented and not with how it will be constructed. It is a set of objects and operation. Objects are the data here, operations are the possible operations like maybe addition, deletion, insertion, searching or sorting. All these things comes under operations on objects or data. All these things together forms a abstract data type. Normally, three things come into picture while dealing with ADTs. One is the data, other the operations we are performing on those data. Third one is the error, possible errors, and how to manipulate these errors when we are in process. These are the three things that associates with ADTs. Advantages of using ADT are they are reusable and ensures robust data structure. Once we form an ADT, it can be used in many situations, in multiple situations. That is the reusability. It reduces coding effort. It's understood from the previous point. If it is reusable, we can reduce the coding also. So coding effort is being dealt with. Encapsulation ensures that data cannot be corrupted. We can securely keep the data by hiding those data with whatever functions that are being available or operations available without disturbing the data that we are storing. It is based on the principle of object-oriented programming and software engineering. So ADTs are based on object-oriented programming, where data is being given the primary importance, and software engineering, where we design how these data is to be handled in a scientific way. It specifies error conditions associated with operations that we have already set as a component of ADT. Data structure is a systematic way to organize data in order to use it efficiently. Following terms are the foundation terms of data structure. Interface and implementation are the two terms associated with data structure. Each data structure has an interface. It represents a set of operations that a data structure supports. An interface only provides the list of supported operation, type of parameters they can accept, and return type of these operations. Then implementation provides the internal representation of data structure. Implementation also provides the definition of algorithms used in the operations of the data structure.